Good afternoon, everyone. All of you are here?
Good afternoon, ma'am.
Good afternoon, ma'am.
Okay. That class is over. Okay, after a long time. So, where we are? So, we are doing that Taylor's theorem, Taylor series expansion, and Maclaurin series expansion. So, this one you have done? Last class I gave you this one.
Screen is not. Yeah.
Visible now?
Yes, ma'am.
Yes, ma'am.
Okay. Done this one? Dull, all of you, or any doubt with this last question what I have given to you?
Ma'am, screen has not loaded it.
It's not loaded.
The screen is visible to us.
Yes, ma'am, screen is visible.
ମୁଁ ତମ ପାଇଁ ସେକିଥିଲି ନେଲ ଟମାଟୋ now back to our work. So is this one, if is it visible now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so the so this one we have done. I just did it, okay, because you are not coming, so I did it. You will do it, or I will show you the solution. Arnab, are you done with this question?
No, ma'am. Ma'am, actually, in the last class, at last I got disconnected.
Okay. Okay, I'm showing you. So this one actually you will consider the Maclaurin series expansion for this exponential function. Okay. Then here. Okay, so you consider you have three terms, so you find the remainder up to two terms. Okay, up to the second derivative. So this is what the theta is from 0 to 1. Okay, so this is the Maclaurin series expansion of the exponential with a remainder up to two terms. After two terms, we have the remainder. Then here x positive, so here 0 and theta lies between 0 and 1, so here you consider the right side, then e power theta x less than equals to x. Okay, so now we multiply it with this one, 1 plus x square by 2 factorial, and this one is nothing but the e of x. Then for x positive, now we will consider this left hand side, this much. Okay, so here we are getting, it's just the application of Taylor series. Okay, this in the similar way, if you consider this one, we are getting here in the first one, we consider this one right hand side, and here we consider this one. Okay, okay, now you can compare both the inequality. Okay, so this is the middle part, and this is what we have. Okay, now this is how we did. Okay, it's a simple one. Okay, only thing a little permutation combination. Okay, you have to do. Is it clear or any doubt?
Ma'am, in remainder theorem, why you write theta x e power theta x?
Because see here actually the interval is 0 to x, isn't it? Okay, if you put it 0 to x, and if you consider theta from 0 to 1, you actually in the Lagrange's form we get a c which is in 0 to x, and here theta is 0 to 1 means this one is within 0 to x, theta x. Got it? No, it's one of the standard methods. Like if you write c, I used to write c belongs to 0 to x. Okay, So it's the same thing. Instead of C, I have written theta x, where theta is from 0 to 1. Got it? So now we will do a little more. So see, all the normal, at least we know how to go for Taylor series and Maclaurin series. So one more question we will do. Okay. So write down. So now we will do one for the algebraic function. Okay. Expand the polynomial. So there are some different terms also for this one. Okay. Expand the polynomial. Fx equals to x power 5 plus 2x power 4 minus x square plus x plus 1. So we will expand the polynomial in powers of x plus 1. X plus 1. Okay. So you see how you will do. It's just one of the form. Okay. You can rewrite we are expand this polynomial in powers of x plus 1. So you can say the other way is you find the Taylor series expansion of this f of x at what point? How you can write this one as Taylor series expansion?
minus
In,
1.
at minus 1, this question is same as obtain the Taylor series expansion of f of x about the point x equals to minus 1. Or find the Taylor series expansion find the Taylor series expansion of f of x about x equals to minus 1. Okay, so these are the similar things. Okay, so now you can solve this question, I think. Try and do this one. It's an easy one, algebraic function, so you find the derivative. So yeah, it's a fifth degree polynomial. Okay, so try up to fifth order derivative. Sixth order will be 0. So go up to fifth order.
Ma'am,
Yes,
ma'am, since we have not got the books, ma'am, can you share the PDF of the book you have said, the reference book in the classroom?
you have Jen Anger book and Crazy.
No, ma'am, we did our branch didn't got the books.
Okay, because the other
We have not.
branch, which branch told me? IT told me. So I said you at least the chapter you can scan and distribute among yourselves. Okay, you can get it. Your friends are there, at least the chapters.
Yes, ma'am.
Okay. From Jen Anger book, you try and get that chapter. Which chapter? Let me see which chapter. If any one of you will get, you can distribute among yourself. Let me
Okay,
see
ma'am.
if I will get it and I will do it. Okay. But I
Okay.
think already it's already with other sections, so you can get it. Only the
Yes, ma'am.
chapter is enough. Any doubt with this question? The same process. You find the Taylor.
I'm done.
Okay. So what is your answer?
Yes, ma'am.
X plus 1 whole
X
square.
minus 1 square plus 2 x minus 1 cube minus 5
X
x
plus
minus
1.
1 to the power 4.
X plus 1.
Ma'am, x plus 1 whole raised to 5 minus 3 times x plus 1 whole raised to 4 plus 2 times x plus 1 whole cube minus 23 times x plus 1 whole square minus 2.
23 times.
Ma'am, x plus 1
Yes,
whole to
ma'am.
the power 5 plus 2, 2 whole x plus 1 whole cube minus 3x plus 1 whole to the power 4 plus x plus 1 whole square.
Yeah, but x plus 1 whole square coefficient must be 1. Okay. Other three.
2.
Okay, let's do it. Okay. You will tell me I'm directly writing. So first f of x we have. So what is the value of f
Ma'am,
of
sorry,
minus?
ma'am, that 24 coefficient is not minus 23, it's plus 2.
Okay. So what is f of minus 1?
0.
0.
Then f dash x. So you find it. Okay. I'm only writing the value. F dash.
0.
Is it 0?
Yes, ma'am.
Then the second order
Yes,
derivative.
ma'am.
Two.
Minus 1.
2.
2.
2.
So it's a fifth degree polynomial. So we will find up to the fifth order. Okay. And this one, third at minus
12.
12.
now fourth
120.
and
168.
20. How much? Fourth derivative at minus 1, how much you are getting?
Minus 120.
Minus 120.
120, ma'am, plus.
Ma'am,
It's 120. Yeah. No, ma'am. Fourth minus 72.
Yes, ma'am, fourth minus 72.
Minus 72.
Minus 72. Fifth 120.
And this one,
Plus
120.
120.
120.
120.
then sixth one,
0.
1 0, ma'am.
0, ma'am.
0. Okay, so it's 0. So we will substitute here. Okay. Karade, you have to find this one or should I write? Find this one. Okay. Then next thing is we will write down the Taylor series at x equals to minus 1.
Call
At x equals to minus 1, so the Taylor series of f of x. So after substituting the above values, what we are getting is f of x equals to,
X plus 1 whole power 5.
okay, see, I'm directly writing. Then
Minus 3 times x plus 1
Minus 3.
whole raised to
Mi-
4.
Minus
minus
plus 2.
Plus
X
2 x
plus
plus
1
1
whole
whole
power
raised cube.
plus x plus 1 whole square.
Minus 2.
again minus 2.
Yes, ma'am.
Only this much.
One more term, ma'am, minus 2.
No, ma'am, no minus 2.
No, ma'am, it's all.
Minus 2.
No, ma'am,
Okay.
that's it.
And now a little one compound function we will consider also. See how you will find. So here. Find the first 7 terms of the Maclaurin series. Okay, ln sec x. Okay, so here you have the compound function ln sec x. Okay, so let's try Maclaurin series. Just have the idea. You can also have this polynomial function. You can have this compound functions.
Ma'am, answer x
Yes.
square by 2 plus x power 4 by 12 plus x power
Yes.
6 by 45.
Okay.
That's it.
Okay. 3
7
terms.
times. I mean, so the
Other
x power
terms
6.
is it?
Ma'am, that's it.
Okay. Others? Any other answer or this is the right thing? So Maclaurin series, so at 0 you will find.
Yes,
So
ma'am, that's right.
what is f of 0 here?
0.
0. ln 1 is 0. So make it 0. Now f dash x, how much is
Tan x.
it dash x? Tan x. Tan x.
0 f dash 0 0.
Now the second derivative.
Secant square x. 1.
Third derivative.
2 secant x tan x. 2 secant square x tan x. 0.
So at 0. 0.
Yes, ma'am.
So here you can see we have 3 terms 0 by now on the fourth derivative. So others you say if I'm doing any mistake. So say. So what is the fourth
2 secant
derivative?
power 4x.
How much you said?
2 secant power 4x
2 secant power 4x
plus 4 tan square x
tan square x.
secant square x.
Now what is
2.
at 0?
2,
2.
ma'am. 2.
1/5.
6 secant cube x into tan x.
8
16.
secant secant power 4 tan x plus 8 secant square x tan x.
This value is
0 0.
So we need sixth derivative also, 7 terms. Okay, this is the seventh term. So what is
Yes,
the derivative?
8 secant square x 24 tan square x
Multiplied by
8 secant square x into 3 tan square x secant square x
again.
yes ma'am, plus 16 secant square x tan power 4x plus 64
Plus 64.
secant power 4x
So here
yes
also second for
tan
and
square x tan square x plus 16 secant power 6x answer 16 ma'am. Yep, 4 4 16.
so others you look at the derivative.
Yes ma'am.
This is 0.
No ma'am, 16.
16. Okay. So here you see 4 terms are going to 0. Okay. So on sec x. F of 0. So if you write down, your answer will be Maclaurin series. So
X by
x 0.
square by 2 factorial.
And it goes on. Okay. Now we will substitute here. So after substitution, you will be getting another 4 zeros.
X square by 2 plus x power 4 by 12 x power 6 by 45
4 x power 6 by 44.
45 45
45. It's same for others.
Yes, ma'am.
Okay, we directly look at the
Yes, ma'am.
derivative. Okay.
Yes, ma'am.
Then,
Ma'am.
okay. One more question. And we have a compound function. Okay. Expand. So here the function is sine ln x square plus 2x plus 1. Okay. So sine ln x square plus 2x plus 1. So here also we have a composite function.
Maclaurin series ma'am.
Yes. Like you have to expand in the series, so Taylor series. Okay. you remember any of your Leibniz rule that you can try for the nth derivative?
Normal derivation, it becomes tough, man.
Normal derivation?
It becomes
Yes, ma'am. It
difficult
is very
to solve
It's very tough, man.
by using what you say or method that.
chain rule. We will use this.
That Leibniz theorem, there is one u, v, and nth derivative. How you find u and v plus nc1 u and that chain rule you remember? That is known as Leibniz rule.
No, ma'am. Don't know, ma'am.
For this two function to be multiplied, here nothing is multiplied.
Okay.
Yes, ma'am. True, he said.
So first, what you do? Okay, differentiating y with respect to x. You differentiate this one first. Okay. Then again you differentiate. Okay. So then first derivative, then the second derivative. Okay. Then you use the Leibniz rule. Okay. That time.
First, we can simplify that inside one x plus 1 whole square. Then we can do 2ln x plus 1.
Okay. Okay. Let's see what happens. Okay, it's a little bit longer one. Okay. Should I do, or it is? You think the derivative is much hard? Because you have to use some relations also. Okay, okay then. Let me
Third
give.
order is becoming difficult,
Ah,
ma'am.
yes, yes, and the third order only you will be getting. So that nth order. Okay, instead of that you write easier one. Okay, exponential e power x and sine square x. That will I think easier. Okay. So instead of that, you consider e power x sine square x. Okay, it's a little complicated derivative. So make it e power x, and this is here up to x power 5. Now yeah, this derivative, I think it will be e power x sine square x. I think let's see, e power x exponential into sine square x, and up
Last
to
problem, ma'am.
last one, you find it. This third derivative is really tough. You have to use that
Yes, ma'am.
n time derivative of Leibniz rule, but that will be actually really tougher. Okay, the derivative. Okay, leave that. The important thing is you should understand the concept. Okay. Here also multiplication is there, but you go for the series, and like I did the series of. If you go for the, you can do in general way, or you can also consider the series of the exponential and sine square x, sine x square, and you can multiply, find out first 5 up to x power 5. That is one way, or you can try for one derivative and do it. That one example in the last class I did, no, where we use the sin x series. Here that also, here also you can do that way, or the normal standard way.
Means we can expand that e to the power x and also sin x, and we will multiply up to that x to the power
X
5.
power 5 term that you can try.
Yes, ma'am.
x plus x square plus x cube by 3 plus x raised to 5 by 20.
You're telling me the answer again?
X plus x square plus x cube by 3 plus x raised to 5 by 20.
X term is not there. It won't be there, you see. Because sine square, sine term x starts with
Ma'am,
x.
X term is 0, ma'am. X term is 0. X term is not there.
When it starts with x square. Because sine
Yes, ma'am.
square x is there. Okay, in which way you are doing? Whether the multiplication way or the standard form you are doing? So if you look at the series, this series will be 1 plus x square factorial. So this one is the series of exponential. And for sine x, we have x minus x cubed by 3 factorial plus x power 5 by 5 factorial. Okay, so this is how. Now y equals to e power x sine square x. Okay. So here you can write down the series there. So it will be 1 plus x square by 2 factorial. See the standard form also you can do. Then here for the sign.
Hello, ma'am.
Square.
Ma'am, just
Yes.
convert sine square x into 1 minus cos 2x by 2. It will be much easier.
That will be again much easier. You can do that way. Okay. 1 minus cos 2x. Is
So
it?
here cos 2x will be 1.
And
That one will be
yeah,
cancelled.
you can write down the series of cos 2x. This is also one of the way. Okay. You can try. Okay. Since I have written, I'm doing it this way. So here 1. Okay. If you look at here, what we will do, few terms we will write in the square part, or that one in this cos 2x also, it's much easier, right? Okay, you tell me. That is, since we will have the linear terms, we will go for this, like not square. So what will be the series here for 1 minus cos 2x? 1. Who is telling? You say about 1 minus cos 2x. What is the series?
Yes, ma'am. 1 minus
1 minus.
in bracket 1 in bracket 1 plus x square by factorial 2 plus x raised to 4 by factorial 4. That's enough, ma'am. No, no, only 5 times it.
Ma'am, 2x, ma'am, 2x whole square
2x
plus
Ah,
1
square.
2,
minus
2x whole square. So,
So let me write here 4.
and then 16.
2 power 4. That's right. Since I'm writing 6, there are only 5 terms. Let me write 6 here. And here y also I can write e power x into 1 minus cos 2x.
Whole upon 2.
Okay. So here this 1 gets cancelled and all are with negative powers.
Yes, ma'am.
So minus 4x square by 2 minus 16x power 4 by 4 factorial. Okay. So 1 plus x square by 2 factorial. And here we have, so 1 by 2 is there, so we will cancel here 2. Let me write later on. So here the first term, what will be the first term? 4 minus 4x
minus 2x
squared by
square
2
minus 2x square.
minus x square.
minus x
Yes, ma'am, minus x square.
minus x squared is the first term.
Then minus x cube.
Minus x squared, then
Minus x cube.
minus x cube.
Then minus 17 by 30 x raised to 4.
17 by 30, it is coming 1 by 6. But what I am getting is the positive terms. Okay. X square, then plus x cube plus
1
1
plus
by.
x to the power 4 by 6 minus x to the power 5 by 30.
No, no, first, what is that x power 4? What is the term?
X to the power 4 by 6 minus x power 5 by 30.
Plus all the terms you are I'm getting plus the last answer. If you see, this is also divided by 6. So how we take care of minus? Did you miss anything?
Ma'am, my fourth and fifth term are not matching. X raised to
But
4
this
and
is the
5.
answer actually. See, if you let's look at here. Okay, x. So first term will be x here. Then we are getting x square here.
That will be minus x
Here
power
x
5 by
square.
6.
First term will be x square here. See, if you look at here, the first term, the square term, first term will come x square. So here x square. So x square has to be the first term. Got it? Like I'm looking at this term. If you go for the square, here first term will be square, x square. So here x square into 1 is x square. Now the next term, if you multiply here x cube, because the other terms are higher terms. So if you multiply x square here, so first two terms are right. Now
Yes, ma'am.
you look at the third term. Okay.
Ma'am,
First term.
here you wrong, ma'am. Expansion cos 2x expansion. No, ma'am, that wrong, ma'am.
Something we missed somewhere.
Plus minus
Plus
x.
minus, ma'am. First 1 minus 4x square by 2 factorial plus 16x square. That's
It will be plus
I
minus
missed
plus minus.
something. Okay. Here minus. Then
Yes,
are
ma'am.
we getting what we are doing? Because it's an exact thing, no? So answer should be same. Whether you proceed in this manner or that manner, answer should be same. We are getting
answer
the
same only, ma'am.
at least the first few terms are exact. Even if the series means the approximation, but the fewer
डाल
terms
देगा ये वो
will be same. Okay.
रेटिंग घट जाएगा रे इंसान का रेटिंग घट जाएगा ये लोग अपना ही ढूंढ रहा होना मतलब अलग लेवल पे ये लोग
Okay. So you can do it like this. And one last thing, let me write. Okay, you will do it using Maclaurin series so that. Okay. So this you have to show using Maclaurin series. So do it. Okay. Only take 2-3 minutes. Where are others? I can only hear few of you. You left. You try in Jayanangar book also very good exercise. There many problems are there. But the mean value theorems also, then indeterminate form, then here Taylor series form. So you can proceed in the same manner, or you can also use the series expansion of the exponential and x cos x. So whichever way, you should get the same result. You have to prove, right? Done, any of you?
Yes, ma'am.
Yeah. What is your stance? Are you getting?
Yes, ma'am.
So how you are proceeding? Is that your form, or you are going for the exponential and cosine
No,
series?
ma'am. Maclaurin series means Taylor series.
Maclaurin series. So how? What to do first? This is your f of
First,
x.
f of 0 equals to 1.
Then f dash.
F dash of x equals to a raised to x into sin x plus cos x.
Sin x plus cos x.
No, no, cos x minus sin x.
Okay.
Minus. Yes. That also 1.
Then
Then a raised to x cos x minus sin x minus cos x minus sin x. Means 0.
0, ma'am.
how much?
0, 0.
0.
सॉरी मैम बट यहाँ पे e टू द पावर x cos x यहाँ पे
Yes,
cos x
ma'am.
पावर में
You
था
are
या
taking e to the power e in the derivative. How is that? It should be e
Ma'am,
to the
it
power
power.
x cos x. In the power, it is cos x, no?
Yes, ma'am. Power it is cos x. No.
The
Yes.
second derivative, how?
Okay. So
This is
here.
not multiplication.
So you are not getting, ma'am, answer by this.
Now you are getting the first derivative is right?
No,
No.
no, ma'am, that's all wrong, ma'am.
No, no.
Anyone done in this method? Or you are doing the other way?
मैम बस थर्ड टर्म नहीं हो रही थर्ड डेरिवेटिव नहीं आ रहा
Third derivative.
थर्ड डेरिवेटिव में थोड़ा प्रॉब्लम हो रहा है, बहुत लेंदी हो रहा है, सेकंड तक
Yes,
आ गए।
ma'am.
Yes, ma'am.
Yes, ma'am. Same here.
Ma'am, I have solved up to third degree.
Oh, what is your third derivative? Is in the power. Wait a minute. Okay, so, but are you arriving at the answer?
Yes, ma'am.
By third derivative, you are getting the answer. What is your third derivative?
Ma'am, it's lengthy. E power x cos x.
And you are able to get your proof. That's
Yes,
what
ma'am. Up to third degree.
like first four terms you are getting. What you have to prove.
Yes, ma'am.
Let's say. So let me do it this way. Okay. So this is we know x n by n factorial. This is the series expansion of e power x. Okay. Then we have e power x cos x. So it will be x cos x power n by n factorial. Okay. So here you have to use also the series of cos x. Okay. If you open this one, this will be like 1 plus x cos x plus x square cos square x by 2 factorial plus x cube cos cube x by 3 factorial. So this is how you will proceed. Okay. Now x cos x. So what is the series for the cos x? X into this is x power 2n by 2n factorial and here minus 1 power n. So n from 0 to infinity. Okay, so this will be
1 minus cos x expansion.
1 minus 1 minus which one I left?
I mean cos x equal to 1 minus x power x square by 2 factorial. That's no, ma'am. By this way.
Yes. Again, could you tell me?
Okay,
Cos
ma'am.
x equals to
Cos x equal to 1 minus x square by 2 factorial plus x power 4 by 4 factorial, no, ma'am. That's
so that's what we have taken. If
Ma'am,
you
can you show the beginning of the solution again?
I didn't do anything. Okay, first this is the series of the exponential. Now instead of x we have x cos x. So I have written here. So this one is the series for this one. See, this is x power 2n by 2n factorial. So for n equals to 0, we have 1. N equals to 1, we have x square. Right? It is what it is coming. 1 minus x square by 2 factorial plus x cube by x power 4 by 4 factorial minus. So alternating sign is coming. You see it's 2n. So what you are saying, it's the same cos x. And here since we have 1 power of x, so we will take it inside the series, this one. If you want, you can open it also. Okay. So here now we will substitute this series here in the e power x cos x. Okay, so e power cos x 1 plus x cos x, we will write it like this. So here even we don't have the multiplication, we have only the addition. Then we have x square by 2 factorial. Okay, so 1 by 2 factorial. So here this is the square term is there.
It's 2.
Square is there, right? And there is one more. Here also calculation is there. Okay, and this much you have to go for the a little bit of you have to do the calculation. Okay, so now you have to open also. If you want, you can write also here 1 plus here. This is the x cos x, so what happens here? X minus x cube by 2 factorial plus x4 by, so here x4, so it will be x5. Got it? Now here plus 1 by 2 factorial. The same thing we will write here and the square term.
Ma'am, but we have to solve it by using Maclaurin series, no?
So same thing, we are using the Maclaurin series of the exponential. See what I have written, this is the Maclaurin series of exponential only. At 0 we are expanding. And for cosine, what I have written, this is the Maclaurin series of cosine only. Okay. So you can also do it that way. That is also another way and this is. But finding derivative will be a little tough. So that's why I have written this one. Okay.
Ma'am, answer
Have I
this.
cleared that those two things? I have written it directly.
Oh,
Have
yes,
I?
ma'am.
So I'm writing the answer. You will do the calculation. So what is the answer? 1 plus x square by 2.
No, ma'am. One simplest step is there.
What?
It means we have 1 plus x cos x means it is to x cos x expansion, na?
So you will
So
go for
like
the
previous one, cos square x in we can write 1 minus cos 2x by 2.
But where is cos square
And
x?
in no x square cos square x by 2 it's there, na?
Previous one.
In expansion. No.
This one.
This
Here.
question only, ma'am. Yes, ma'am.
Okay, this one.
Yes, ma'am.
This
And
one in cos 2x form and this one in cos 3x form. That was
in third term we will write only 3 terms
cos
because after
3x
that
form.
it will be exceeding fifth or sixth power.
Yes. So it's up to you. You can go for cos 2x form and here also, or you can do this way, and you can also do the general form like the direct Maclaurin series. You can also find by finding the first, second, and third derivative. Okay. So here this is first term is x. Okay. Then the second term here we don't have x square. Here the term will come x square by 2 factorial. Okay. Now for the second term we will have x power 4. And here we have x cubed by 2 factorial. Here we have x cubed by 3 factorial. Okay. So that we have to take care. Here it is x cubed by 3 factorial. And here minus x cubed by 2 factorial. So minus term will come. Okay. So here 1 minus 3. How much will come? X cubed by 3. Okay. So rest of the terms will have higher powers. Okay. So you got it. So only the first term we took here. Here x square term we got it. And this x cube by 2 factorial. Here the second term will have power x power 4. And here the first term will have x cube. So this x cube. Okay. Okay. No, it's my daughter actually. Okay. So we are all in quarantine phase. Okay, all of you doing well. So now we have done something. Okay, now here,
Ma'am,
yes,
it should be 1 plus x cube by 2 factorial.
yes, x cube by 2 factorial minus x cube by 3 factorial. The two terms we are getting here. See, this is the term x cube by, here we have minus x cube, and here the term won't consider because the second term will have x power 4. So here
Yes, ma'am.
cube x cube by 3 factorial. So here actually x cube by 3 factorial minus x cube by 2 factorial. We are getting x cube. See, x cube by 3 factorial minus x cube by 2 factorial. This is the term. Okay. So here x cube by 6 minus x cube by 2. Are you getting x cube by 3?
Yes, ma'am.
This is x cube by 3. The rest of the terms will have higher powers. So, okay, this is done. Any doubt? Sorry. Okay. Any doubt? Yes, any doubt? What is that? Sudhanshu.
No, ma'am. It just pressed due to cold.
Okay.
Hmm.
So, no doubt? No, it's
No,
not.
ma'am.
So you can proceed in any way, right? What you are saying, you can go for cos 2x also. You can, from the starting also, you can say you can use Maclaurin series. See here, I have written to this one. This is the Maclaurin series. Okay. This one is, it's only the Maclaurin series. That's you see, it's the Maclaurin series, expansion at 0. Then the cos x, what you are finding here, this one's also Maclaurin series. We are using Maclaurin series only. Okay.
Ma'am, then in exam, if we are asked
It's up
about
to you. You can do in any form, but there is one thing. These are
okay,
the exact answers, so you should be getting that, what you are proving. And do your calculation properly. Okay.
we can use any method, but we have to get two
Any
right
method
answer.
means you should use Maclaurin series only. Here also see this one's Maclaurin series. If you do directly as you
Yes,
said y
ma'am.
equals to e power x cos x, then you find y dash, y double dash, y triple dash. The third derivative was a tougher to find. So it's up to you. It's only for the sake of calculation. You can directly find this one as your f, then f dash, f double dash, triple dash, then find the corresponding values at 0 and solve it. Okay. You got it?
Yes, ma'am.
Yes, ma'am.
Okay. So it's up to you, whichever way you proceed. Okay. And the calculations. So now I think you have some idea, okay, how to do for this compound, different types of Taylor series and Maclaurin series. And we are going to use this Taylor series, Maclaurin series very often, okay. Then like in the multivariable calculus also we have this Taylor series. That means we will be doing for the two variables. Here we have only one variable. So there we have two variables. There also we will see. So just do it properly. And in your Jan Anger book also, it's there are many sums in the exercise. I was just now I was saying. So if you are getting it, it's good. Okay, from your friends, or I will if you by the next class you try and get it from. I think it's there with IT or C or other sections. So if
Yes,
you
ma'am.
can get the scanned copy also, that's good. So I will share one of you tell me your ID. Let me do this one try. One ID I will share and try to share among yourselves. So whether it's working or not, you let me know. Okay. Yes, for one of the ID you say. Your CR you can say.
Ma'am, ID 65.
B1 say like that. B1
Ma'am,
1
B121065.
2 1. B121065.
Yes, ma'am.
Address then.
Yes, ma'am.
Okay, you cannot see. I think I have stopped. Okay, B121065. So I'm sharing this notebook with you. Okay, if you can see, you try to share it with others and see whether others can see it or not. I
Okay,
just
ma'am.
mailed you. Okay, shared it with you. You check and share it with others if it's coming. And by the next class, by tomorrow, you tell me whether you are able to see this or not. Okay. Done. So we will finish our class now. End our class. Okay. Just do the problems. Try to get that book, or you let me know tomorrow. Again, I will try and get the scanned version copy. Okay.
Ma'am, in the book there are some remainder form of Rn. Are they important?
Very important. Just a little variation. Okay. But you know this Lagrangian form. Okay. If you want, you can go and know it. Okay. This little variation is there. Nothing else. But this one, what I'm teaching, it's the Lagrangian form. It's most widely used. Okay. And we are
Okay.
going to concentrate on this only. Okay. If you want, you will see it's just a little variation. Okay. Okay then. I'm ending the class for today.
Thank you, ma'am.
Thank you, ma'am.